Hello, and welcome to another episode of Network Forensic Fundamentals. My name is Phil Hagen, and in this episode, we're going to be talking about TCP Dump. This is one of our core tools that we use for network forensic and a lot of other purposes, and it's something that is really important for us because you can use it in both capture as well as analysis workflows, and we're going to cover both of those. TCP Dump also incorporates a lot of capabilities, some of which we've talked about already, that make it an incredibly high performance tool that's really important to have in our toolbox and, of course, to know how to use it. I call TCP Dump a foundational tool because I would unscientifically estimate that gig for gig, it's probably one of, if not the most widely used network traffic capture tools there are. Now, let's be honest, we're probably not using TCP Dump for petabyte scale collections, but when we talk about the millions of times per, day, month around the world that TCP Dump is used for some form of even very small scale packet capture, it ends up being something that's very widely used and certainly very helpful for us in those different capacities. Now, in terms of what TCP Dump brings to the table, there's a couple of main characteristics and capabilities that I want to cover. First of all, it is free and open source, which means we have the ability to use that without needing to buy a license. We also have the ability to dive deep into the source code if we ever needed to go that far and potentially to improve it as well. It's also a cross-platform tool, meaning we have the exact same tool, the exact same workflow and command lines that we can use across multiple different operating systems. So whether you're operating on a Linux system, a Mac OS system, or even the ports that have been made to Microsoft Windows, you've got a familiar tool in TCP Dump. And as I just mentioned, it is command line based. And I think this is a huge benefit because it means we can automate processes using TCP Dump through the use of things like shell script or even well-documented procedures that have well-formed, vetted, validated command lines so we can have repeated outputs. We have a similar process for multiple different use cases. One of the topics that I did touch on in a previous episode here is that libpcap is an incredibly important piece of code. This is the library that provides, among other things, the ability to create or handle PCAP files. Now, libpcap is separate from TCP Dump, but as we're going to see in a lot of our different tools, a lot of network capture tools do use libpcap under the hood, which means they give us a lot of the same benefits. And some of those benefits include, first of all, the ability to read from either a live network interface or from an existing packet capture file equivalently. There's no difference from a libpcap enabled tool's perspective, whether it's reading live data or whether it's reading capture data that's already been created. That's going to be really important because, again, it depends on whether it would be irrelevant whether you're looking at a live analysis or live collection workflow or something that's already been put into evidence. You've got a similar tool that's going to be able to provide the same capabilities. libpcap also provides the ability to write to a file or to display basic information to the command line as well, or to the terminal that's calling it. And this means that we can actually create PCAP files. And that ends up being a big benefit for us when it comes to a network forensic workflow if you are doing that kind of network collection. And then, as we touched upon on the last module, the Berkeley packet filter. Now, if you haven't seen the last episode, please do go back. Make sure you take a look at that one because we cover the BPF and we cover what it does. Just put very quickly here, the BPF, the Berkeley packet filter, is a filtering language that provides extremely high performance decision making from the tool that's using libpcap on whether the tool is going to handle or ignore every single packet that it observes. Now, again, because we are dealing with such a well-constructed, well-vetted set of code, a lot of our free and open source and even our commercial tools use libpcap for their network capture as well as their network reading and their writing of network data into PCAP files, which means we've got a common, consistent file format that we can use for lots of different workflows, which, as you're going to become familiar with, is a big benefit for us because it means we can learn a technique, a procedure, a tool once, and it can apply to a lot of different use cases. And that certainly represents a big benefit to you and I as the analyst. Now, the basic usage that we're going to start with TCP Dump is simply doing traffic capture. So think a live network interface and I want to create PCAP files. The BPF is going to allow capture minimization, but we can't guarantee that we're going to get every single packet. We still might lose some of those packets. Now, that might be through resource exhaustion. That might be through bandwidth constraints on a network interface. That could be from a whole variety of other parameters or other restrictions. But the idea is we can't guarantee we're going to have 100% complete full packet capture. So we may want to use that BPF in order to minimize the capture so that we can get just the data that we're interested in. And if you remember back to how I was very, very excited about how performant the BPF is, that means that we can push some of those more expensive decisions down into the kernel, and we, in user space, for example, with TCP dump, are going to be left with just a minimized, pre-minimized set of packets to work through. So let's go ahead and look at an example command line. Now, this is extremely basic, and I'm going to talk through a command line with you component by component so that you can understand a little bit about this basic use case. First of all, we're going to probably want to run TCP dump with sudo, especially if you're doing any kind of live network capture. The reason for this is in order to capture any kind of Ethernet frame that's being sent to any MAC address other than your own, the network interface has to be placed into what is called promiscuous mode. This is generally a Linux-centric concept, but the same general concepts do carry forward to Microsoft Windows as well. But sudo or some other means of elevating privileges is generally going to be needed if you're reading data coming from, let's say, a port mirror on a switch, or potentially from a tap or some other type of packet duplication technology where you're getting Ethernet frames that are designed for someone other than your own network interface card. So when we're running capture, we need sudo. As I'm going to show you in some other examples, though, if you're not actually capturing, you probably don't need sudo, and we're going to give you examples of those coming up. The TCP dump command is simply TCP dump, but now we start adding on a number of different command line parameters. We start out with one that's the -n option. Now, this is one that I'll be honest, I am unable to type the word TCP dump without also typing -n. It's such an important concept. It's burned into my brain and it's become muscle memory. Without the -n option, TCP dump will do a DNS lookup on every single IP address it observes. Now, it's going to be a reverse DNS lookup, but that's still going to be a whole lot of DNS traffic, and that's going to slow things down. It's also generally not needed, so I will almost always disable this. In fact, I can't even remember the last time that I used TCP dump without using the -n option. I disable it because it's just nothing that I need. I don't need to know what those reverse host names are for every given IP address, and I don't want to risk losing capture because TCP dump is busy waiting for DNS responses. The -s option comes next. Now, this is the snapshot length, and if you go back to the episode where we talked about the packet capture file format, the PCAP file format, we talked about snapshot length being the maximum number of bytes that are going to be pulled from any observed packet. Now, in this case, you'll see that I have it specified to 0. This is also a little bit of an old habit, and to be honest, in modern operating systems and modern versions of TCP dump, it's generally not needed. However, I like to include it because the -s0 option means that you're telling TCP dump to opportunistically capture all the bytes in every single packet that it observes. Now, in modern operating systems, this is not strictly necessary. Most of them that I've encountered anyway are going to, by default, opportunistically get as many bytes as they can. But I like to make sure that that's explicitly stated, especially if this is something that goes into my case notes or something that goes into a shell script that I might use later on. That -s0 showing up means I know that the results that should have been coming from that command are going to be opportunistically capturing all of those bytes. The next option that we have here is the -i option with an ENS33. This is telling TCP dump which network interface to use. Now, if you've been on a Mac OS or a Linux system, you know that when you run the ifconfig or ifconfig command, you're going to get a list of the network interfaces. That's where you would choose the network interface name. This might be something like you see here, ENS33. It might be something different like ENP0S3. Might be something like EN0 if you're on a Mac OS system. You get the idea. Lots of different options may be here, but you want to make sure you're looking at the right network interface. In this case, we're creating a PCAP file. We're using the -w option. And the -w says, here's the PCAP file that I would like to create. This is going to then create what we see here as out.pcap, and it's going to contain all of the packets that are observed from ENS33 network interface as specified by -i. At the end of this command line, though, I also specified a BPF. Now, this BPF that you see here is in single quotation marks, which tells the shell to treat the entire BPF as one single statement. It means ignore the fact that there are spaces in there and pass off the entire BPF string to TCP dump. I generally find this is best practice even when it's not strictly necessary, because if you remember back to our BPF syntax and what we're going to revisit with those coming up here, anytime you include things like parentheses, those have special meaning to the shell. And if you don't protect those parenthesis-laden BPF statements with these single quotation marks, you're going to get a pretty strange error message, and it's not even going to be from TCP dump. It's going to be bash telling you that it can't handle the command line. So best practice says put those BPFs in single quotation marks. That's going to enforce the fact that it's that single string. Now the BPF that I have specified here is pretty simple. You're seeing that I'm requesting only packets that are sent to or from a host with an IP address of 1.2.3.4, and at the same time, a source or a destination port of 80. And if you remember those BPFs, host is going to let us specify an IP address. Port is going to allow us to specify a layer 4 port number if that is available. And any packets meeting all of those characteristics, because we've got them ANDed together, is going to then end up in the out.pcap file. Now, this is, again, a very simple example. There's a couple of references that I want to point you to that are going to help get you a little bit more familiar with the extensive filtering syntax and the extensive number of command line options that TCP dump provides. The first of these is going to simply be the manual page. If you're on any Mac OS or Linux system, you can simply type man space TCP dump, and you'll get an online soft version of the documentation for that specific version of TCP dump. Very handy. There's also another man page called PCAP filter, which is super helpful when you're troubleshooting or trying to explore the capabilities of the BPF in particular. And then another guide that you might want to check out, Sans has provided the Linux Shell Survival Guide handout that I created for Forensics 572. And it's a real handy little trifold document. You can download it for free. It's a PDF form, print it out if you'd like to do that. And it's really designed to be that quick reference to a lot of the common network forensic command line tools. I'll add a link to that in the show notes that you've got down below the video here. And it's something that I do keep handy just because even I don't remember every single one of those command line parameters all the time. Sometimes it's nice to have that real quick reference. And sometimes the man page, although it's extensively covering the capabilities of the tool, it's going to be very verbose. So the quick reference guide might be handy there. So feel free to check that out if you get a chance. Although we just covered the basic example of using TCP dump for capture, we can also use it for data reduction. And data reduction is what I'd consider to be one of the more common needs for us in a network forensic world, because if you're given a large amount of packet capture data and you need to reduce it down to something more manageable, you can use a BPF to take an input file, run a BPF filter against the input file, and generate an output file. And if that output file is smaller and more manageable, it means it's more accessible through a larger number of tools. So really handy way for you to take that terabyte worth of PCAP data, reduce it down to a few hundred megabytes, and feed that into Wireshark or maybe Zeek or some of the other tools that you might use for network-based analysis. If you look at the examples here, I'm using another tool or utility that comes along with the Wireshark distribution called capinfos. And in this case, I'm running capinfos against bigfile.pcap. Now, the command line options that are here are basically saying here are the different metrics or the different statistics that I'd like to get from the PCAP file. Capinfos without those options will give you a much longer list. So not only to make them a little bit more convenient here on the screen, but also just to show what's most important, I'm just looking at the file name, the number of packets, the file size, and then the data size. And the difference there is that file size is the entire PCAP file. Data size is going to be the size of the actual packets. And if you remember back to the section where we talked about the PCAP file format, we had overhead. We had 24 bytes of file overhead. We had 16 bytes per packet of packet headers. Then we had the actual packet data. So in this case, data size is just referring to the payload size. So if I run that against the first file, you'll see that I'm looking at a pretty large file. Now, I'm not going to try to do the math here and try and calculate out exactly how big that file is, but you get an idea that that's quite a large number of packets. We're looking at almost 19 million packets in this file. So let's say we wanted to pull out just a subset of data. And let's say we wanted to pull out some data that rules out something that is traffic that's already been analyzed or we've already ruled out as relevant. I might use a TCP dump command to do that. If you look at this next TCP dump command, you'll see I'm not running it with sudo because I'm not capturing data. Remember, that sudo or elevated privilege is only required if you're doing some form of live capture because you have to set that network interface into promiscuous mode. In this case, we're simply reading a PCAP file, which means we still have to worry about file permissions, but as long as the user running TCP dump has permissions to read the file, in this case, create the output file, there's no other elevated privileges needed. This certainly follows the best practice of least privilege that we try to follow in all of our procedures. So in terms of these command line parameters, once again, I'm using the -n just because that's best practice. It's kind of a habit and muscle memory for me. I'm now adding in another option, the -r option. This is going to say which PCAP file do I want to read in. So where the last example, we specified a network interface to read from, in this example, we're reading from bigfile.pcap, which we've already examined briefly above with the capinfos command. And we're using the -w option, just as we did previously, to create now smaller file.pcap. But as we look at the BPF, we get an idea of what should show up in that smaller file.pcap. It's only going to be packets that match the conditions specified in the BPF. And in this case, we're looking at, I only want packets that are not port 443, not using a multicast net block or CIDR block, that's the 224/4 option you see here, and also not port 53. So although we can't guarantee the content of those, we're generally saying, I don't want HTTPS, I don't want DNS, and I don't want multicast traffic. There's a little bit of a leap of faith involved here because there's nothing that guarantees that port 443 is always going to be HTTPS, of course, but it is something that we can generally state because it is a well-known, commonly used port. Well, after we run this, TCP dump is going to read from the one file, create the other file, and populate the second smaller file.pcap with just packets that match that condition. And notionally, when we run the capinfos command on the resultant file, we see that not only do we have a new file that was created, we see that the number of packets has been greatly reduced. We've gone from about 19 million packets to just under 8 million. And that's a 40-something% decrease in the size or the number of packets there. And we see a similar decrease in size when we look at the byte count. We look at the file size and the subsequent data size has decreased by about 44%. Pretty significant in my view, and definitely something that would be better for me as the analyst because I've got practically half the amount of source data to work from. Now, whether or not this is or isn't suitable for whatever your tool is, that's a different discussion, but 44% reduction is pretty good, so I'm quite happy with that. There are, of course, a lot of different TCP dump command line parameters, and I don't want you to think this is exhaustive. Remember, the manual page is going to be your guidepost, specifically the one that's built into whatever system you're using, not necessarily the one you find on the internet, because the one you find on the internet isn't guaranteed to match the version that you're running. So the man page is going to be your authoritative source of truth. But just to give you a couple of ideas here on some of the other things that TCP dump can do natively, we've already covered some of these, reading from and writing to PCAP files, specifying a network interface for live capture, the -n option to prevent DNS resolution, super helpful altogether. But now let's add on some new ones. We can actually rotate PCAP files. Now this gets to be a little bit of a nuance. We got to be careful on how we use these command line parameters, but we can tell TCP dump, hey, after you're creating a PCAP file and it reaches certain characteristics, certain conditions, I want you to close one file and open another. This is a great way. So instead of multi-terabyte PCAP files, which would be very unwieldy, we might bring things down to maybe 10, 20 gigabyte PCAP files. Those are much more manageable. We can rotate these PCAP files in two ways. We specify the -C option if we want to rotate after a certain file size is created. Now we would say after a certain number of megabytes. We can rotate that PCAP file after a certain number of seconds has elapsed with the -G option. This would, for example, say, I'd like to rotate this after 24 hours, which is 86,400 seconds. We can also limit the number of rotated PCAP files, but this is where I've got to say, be careful. The -W option depends, it behaves differently depending on whether you're rotating based on file size or rotating based on time values. If you're rotating with the -C option, what it'll happen is it'll just keep rolling along. It creates a giant capture, and it'll say, okay, limit the collection of captures, and it will then reach the maximum number of rotated PCAP files, and it will delete the oldest. So let's say I'm rotating based on 10 gigabytes in size, and I'm limiting to 10. That should give me at most 10 files of 10 gigs each, 100 gigs. After the 10th file is done, actually after the 11th file is done, the first file gets deleted. After the 12th file is done, the second file, so on down the line. So you're always guaranteed to have 10 full complete files. Now, if you're using time-based rotation, G option, it's going to behave a little bit differently. What's going to happen here is if you specify the -W option, it will create that many files and then it will quit. So let's say I'm rotating based on every 24 hours and I want to keep 14 days. I would say W 14. I get 14 files and then it ends. I can't give you any first-hand logical knowledge on why those behave differently. They just do. But this is just another example of why it's really important to understand how your tools work. Now, if you omit the -W option and you rotate with either the -C or G options, they'll just keep going forever. There's one other thing about the G option I'm going to show you when we get to the next slide here in just a moment here. But it has to do with timestamps and the file names. So keep that thought in the back of your mind. We're going to revisit that in just a moment. A couple of other options here that I think are particularly useful. The lowercase z option allows me to run a command against every newly closed or newly completed PCAP file. This is great when you're doing the rotation, because that means as soon as the file is done, we've reached the megabyte threshold, we've reached the seconds timestamp threshold, it's going to then run a command against the file. And if you want to run multiple commands, you put those into a shell script, and then you're running the exact same shell script against your newly rotated PCAP files as soon as they're done. Brilliant automation streamlining approach for you to take. Definitely one that allows us to do some automated post-processing without ever having to lift a finger. It's a very, very smart thing to do. And if we know that our BPFs are being maintained in maybe a series of text files you keep in a source code repository like a Git or GitHub repository, you can actually, instead of specifying them in the command line, use the F option to point to a file. Super handy when you're dealing with those extremely large, complex BPFs, especially if they're BPFs that you need to share with your team members, because then you can put them in a central repository and everybody's going to be more assured of pointing to the latest, greatest up-to-date information. So those BPFs become real good ways for, the -F option becomes a really good way for you and your team to make sure that you're pointing to the same data and using the same references and the same source information. We're going to finish out this section talking about some example TCP dump commands. I'm going to talk through them. You can experiment with them on your own if you'd like to, but I'm going to talk through what the options are, what their implications are, what they mean, as well as how they relate to a potential network forensic workflow. In the first one, we're going to be doing live network capture. So we're going to start out with sudo. And sudo is going to elevate the privileges we can run in promiscuous mode. We're running TCP dump, of course, with the -N option. As mentioned before, that's muscle memory. It's going to be in every single TCP dump command I ever run from now until forever. -S, snapshot length. And for whatever reason, instead of opportunistic full packet capture, in this command, we're requesting at most 100 bytes per packet. Maybe we're just doing some initial troubleshooting. Maybe we're making sure we're looking at the right network interface. Or perhaps we have some kind of space constraints and we don't have the ability to store the full amount of data. Whatever the reason, we can specify whatever number you want there, and then this -S100 means at most 100 bytes will be captured. I'm adding a new option on here, -A, and the -A option says, I want you, TCP Dump, to print out an ASCII-based version of the packet contents. So don't just give me the headers, don't just give me the basics, give me an ASCII-based set of results. This is especially helpful if you're looking at plain text protocols, or if maybe you want to see if you are looking, in fact, at the right network interface by seeing if it's maybe all encrypted or if you've got some mix of different protocols there. I'm again reading from the ENS33 interface, so -I ENS33, and then I'm also adding on a new command line option here that we hadn't discussed previously, another one that is -c. Lowercase c 1000 in this case says, hey, TCP dump, after you get 1,000 packets from, in this case, ENS33, quit. This is a classic troubleshooting or kind of link a testing type of a command where you say, all right, I want to see a lot of data, ASCII, for a relatively small number of packets, 1,000, not a million or more. And I just want to see those results. When you're done, go ahead and quit. I just want to see the beginning of each of those packets. So that's the first example. Gives us a good baseline for troubleshooting going forward. The next example that we have, we're not going to be doing live network capture. In fact, this is simply a variation on the data reduction theme we talked about previously. So we don't need any elevated privileges. We just run TCP dump, but again with the -N, I'm reading in an input file, I'm writing out an output file, and my BPF in this case is just very simple. Only packets to or from this 192.168.23.34 IP address. Maybe that's a particular host of interest that we're looking at, or maybe that's a system we suspect to be compromised by some kind of malware and we want to look at its traffic. We just want to pull in a large collection, reduce it down to a smaller collection of traffic involving the specified host. In the third example, we're going to go back to do live network traffic. So let's put that sudo command in here to elevate privileges, TCP dump -N, just as always. Once again, looking at the ENS33 interface. And in this case, I am writing a file out, but this is where I told you to keep the back of your mind the file names, the date stamps that we need to consider. Now, as you're going to see in just a moment, I am going to be doing a time-based rotation, but my output file therefore must have timestamps in it. Now, of course, we don't specify the individual timestamp. We use a format string. So the output file name in this case is DNS-, and then we see a %sign. Those % are going to indicate to TCP dump, hey, I need you to use a C function called stirftime, and I need you to then go calculate what the date timestamp is at the point when you create this file. %f is going to be year, month, and day. %t is going to be hour, minute, and second. So you can think of these like variables in the string that are going to be calculated when the file is created. So I'm saying dns-date.time.pcap is going to be my file name. And as I mentioned, we're doing rotation. We're doing time-based rotation, so it's the capital G option. 86,400 seconds, 24 hours. I'm going to quit after 14 days. 14 files are created. -W14 tells us keep that many files, and because we're doing date-based rotation, quit. And the BPF we have at the end of here is going to limit us down to just what we believe to be DNS. Even though it might not explicitly be necessary, I include TCP or UDP to begin with, just to make sure that it's obvious that I'm requesting both of those. And on each of those, I'm limiting down to port 53. So there's my BPF there. And just as a little bit of a refresher on that, because we're using parentheses, the single quotation marks become mandatory. You have to have those. Otherwise, your shell is going to try and interpret the parentheses. It's going to become very confused, and you're going to get a cryptic error message. If you don't believe me, give it a try. Take a look. Tell me if that makes sense. It doesn't. The next example that we have here, we're also going to be doing rotation. We're going to be doing a rotation of live network data, so we're using sudo tcpdump-n, same network interface, ENS33, just to keep things consistent for you. Writing out a file called badguy.pcap, and in this case, I want to keep at most 100 megabytes per file. You can see that with the $C100, that's going to say as soon as we go over the 100 megabyte limit, we're going to go ahead and create a new file. I'll talk to you about the file naming for this in just a moment. And I believe that this 204.51.94.79 host is somehow malicious. Maybe it came to me as some kind of threat intelligence. And I'm limiting my capture in the first place to just traffic involving that IP address. Now, before we go on, I want to talk a little bit about this file name. Previously, we discussed how you got to have the format strings for the date and time when you're rotating based on the time, based on the number of seconds. Now we're rotating based on megabytes. So what TCP dump will do is it'll create badguy.pcap, and as soon as it goes over 100 megabytes, it's going to create badguy.pcap1. And then up to 100 megabytes, badguy.pcap2, .pcap3, 4, 5, and so on and so forth. And because we didn't specify a -W, it's just going to keep going until it's terminated, hitting Control-C, or somebody kills the process, or the system reboots, or whatever, there's some kind of error. But it's going to continue creating 100 megabyte files as long as it runs. That is how file size based rotation works. And a little bit of a pro tip here too. You could put a timestamp with format strings in any of these output file names. TCP dump will be more than happy to do that. That might actually make really good sense if you're doing some kind of scripting, for example. But if you don't include it and you're doing this kind of file size based rotation, TCP dump picks right up and says, no problem, I will just change the file name for you. The last example that we have here takes that concept of running a command against a rotated file. Starts out just the same way, sudo tcpdump-n, looking at the ENS33 interface with the -i, I'm writing out a new different pcap file name. I'm saying I want to keep 1 gig file, so I want to rotate after 1024 megs. And every time I create a new 1 gig file, I want to run script.sh against it. And that would have to be in the current directory, of course, so we could specify an absolute path to it. But this means that as soon as the file is created, whatever is in that script is going to be run against the pcap file that was just created. Ends up being an incredibly convenient way for me to do statistical analysis, maybe some triage, maybe some immediate post-processing with tools like Zeek, maybe T-Shark, which we're going to be getting into in a future episode here. Really powerful stuff for you to be able to embed whatever you'd like into that shell script. And that does bring us to the end of this episode. Hopefully you got a good either refresher or a good baseline of understanding of TCP dump. Incredibly useful tool for us in the network forensic workflow. We can use it for capture. We can use it for post-capture analysis and data reduction. We can use it for troubleshooting. It ends up being an incredibly versatile tool in the toolbox and is definitely one that I would recommend anyone doing network tasks, not just network forensics, become very, very familiar with. Hope you enjoyed this episode. We've got a lot more coming for you. Again, my name is Phil Hagen, and this is Network Forensic Fundamentals. I hope you've enjoyed it, and I hope to see you again soon.